Hello and welcome to the episode 5 of OpenTTD Code Deep Dive. In the last episode, I shown the font subsystem, the window manager, and the color palette initialization. We left off with the Blitter initialization, and this is where we are going to continue in this episode. If you find presented content useful, don't forget to press like button and subscribe. So Blitter sounds like a graphical component that will support moving blocks of pixels on the screen. So let's deep dive into it and see what will happen. So Blitter is actually the we can initialize it by the command line, and I think by default it's empty as other things. So there is some global thing I think in a Blitter does that. So if we don't override it via command line, we can just use some globally initialized Blitter here, which I think is not the case since it's empty. And then if it doesn't happen, then the Blitter autodetector is true. And then here is some code that says that checks various conditions. So one of these is that we can have different supports. So either by hardware or the system for, I think it's 8 bits per pixel. So, so let's see what happens here. Okay, this is probably inlined. Get used set. All right. But I guess it will be also not initialized. So if this is empty, or actually if the Blitter is supporting, yeah, so if it says that the Blitter is only about 8-bit sprites, and the support is not none, right? So in this case, it is actually none, so it will not trigger. And this is also false. So then we have the last check, which is this selection of the Blitter. So we said, okay, we try to say Blitter is probably 32 bits. And then if it's empty, we'll just go for this selection here. So let's see. Okay, so there's some Blitter factory function. And what does it do? So we have some sort of blitters here, which is just a static field. Okay, interesting. So it's just the map. It's just the map actually of Blitter factories. Oh yeah, and this is the static function from this Blitter factory. So, and by default, let's see, what do we have here? Okay, so direct object. All right. So as you can see, there are already some factories registers, and I think this is something we are looking at. Some of these are, seems like they are using some optimized version that use some SSC instructions. But well, we just picked the first one. And it would be actually interesting to see it actually forced to use some other one. But let's stick with the defaults for now. So we are allowed with this name. By the way, okay, if it's still empty here, we could go with the default 8-bit splitter. And then we just iterate. So it was this map of the factories. And then we check if actually the name of the factory also matches the name that we passed here. So that's okay. It's probably the same as the key. And then we check if it's usable. Okay, it is. It can be. Some cases it may not be for some reason. but okay, this is just okay. So we get the blitter. Okay, here, those are the blitter factory. And then you can create instance of the blitter. Okay, so in this case, yeah, so this is this 32 bits anim blitter, and it simply returns just the blitter animation, 32 bits per pixel of the animation version, which we'll probably see in action later. So what you can see here now is that it allows some drawing of some rectangular regions, setting pixel drawing rise, so basic dimensional stuff. Scrolling, I think I saw scrolling as well. And this is just assigned to the active blitter, which is just a static field. So this is actually interesting way to just declare some static fields and just have then access to them via some kind of like a singleton pattern, and then we just get an access to them by the functions, which are actually static functions in some classes. Okay, so once it's set up, we return actually the current blitter, which is something else. Okay, so it's actually the active blitter. We just obtain direct pointer. We can also check. Okay, yeah, there's confirmation that the blitter was loaded. That's okay. So we know that this condition didn't pass. So right, we actually get some pointer here. So we have some default blitter setup. And then what we get, we check the video driver, the same logic as with the blitter. We recognize this pattern and we select the driver. And then, okay, so this type is just about the type of the driver we're dealing with. So video, and there's some driver factory base. Let's see. Okay, select driver implementation. And again, we have some drivers here. And yeah, again, same pattern. So we have drivers factory base map, which is just aliased here. And okay, it's obviously not empty. There are some drivers. But we haven't specified the name. So we will just get some, okay, so there's some list of priorities. We start with priority 10 and we get drivers again. And by the way, can we see here what was returned? All right, so we have this IT here. You can briefly have a look, but the important thing is that we have the, okay, so we have some music driver actually, and okay, so now we will check the type. Since it was not the same type, we'll just iterate, and I believe that, yeah, okay, sound driver, many different stuff. I believe we just need to get into here, so let's try. Okay, so now there's a video driver, so the type matches, but there's also the priority. So this priority is 10. So we seek for our priorities. That's actually interesting. Okay, let's see if we can get into here. I will just maybe make some guard, but okay, well, I hope there will be some driver to pick up. So let's see here. And okay, so we get some driver probably. Okay, it's OpenGL driver. It has some lower priority. Okay, so this is how I understand it. So there's some list of drivers. I regret I haven't seen how they were actually loaded, like where the default map comes from. But if there are like many priorities, like each of them have their own priority, and we want to get the highest one that was actually selected as the one that can work in this system. So there's like an OpenGL driver, which gets priority 8 and was first in the queue that was there. So we know that the type matches the video driver here. So this is a general version. So we checked that the general. So in the generic implementation, we just check if this is the video one, and the video hardware acceleration is false, right? And we check if this uses hardware acceleration. Okay, so it does, obviously. So this check will trigger, as I assume, right? Okay, so we won't use the driver. It actually would be interesting to see that we consider a hardware acceleration ping, and I think it could be set up by some again by some property. So okay, so at some point that we get to the drawing, maybe we start from again from the generic one, and then we can check how the OpenGL works with that. All right, but then we have check again for the other case. So we have the driver that uses hardware acceleration, and yeah, and then this is enabled. Then this section will be triggered, but this will not happen. We know that this is turned off. So I hope that we can get somewhere here. Okay. SDL default. Okay. And we take the active driver of the video type, which is, what is it? Again, the static array here. And we have 3 active drivers. It's interesting because they seem empty. Okay. Okay. And then we take the type as an index. Okay, so we have the old driver, which is actually empty from what I see. And then since we have this factory base, we just create an instance of the driver. So in this case, it's just this video SDL default one. And what we can briefly have a look is that, yeah, there's some paint, some generic general video related or graphics related operations. Also something like a main loop after blitter change and so on. Okay, so this is the new driver, and then we call start on the driver. Let's see. So we check the current blitter and check the screen depth. That would be interesting to check. What's the screen depth here? Oh, okay. So it's like 32 bits. It's fine. It's fine. If for some reason it's 0, then it's probably not a real blitter as the comment suggests. And then we just initialize the driver. So what does it do? It updates auto resolution. Okay, in the previous video, I think we were checking this. This was initialized. So if it's 0, then it's reinitialize. But it's not the case. And then we initialize SDL. I think this is SDL function. Yeah, so we won't see. But yeah, it was not in it probably yet. So we set the app name, and then there's some video subsystem initialization for SDL. So yeah, so I assume it's only just not to do it twice. And then since there was no error, then yeah, we are just happy to go back, and then we can find the resolutions. So it's empty for the beginning, and we have many video displays. So so we check. Okay, can I? No, I don't have the SDL here. So we just iterate through the display modes, and we just check what's there. And yeah, if it's too small, then we said okay, forget about it. And then we look up the resolutions. So where's the resolution? Okay, it's this one. So oh yeah, because we have the mode of the monitor. So we have a lookup here of this specific. If we already have such dimensionality, if not, we just fill up the I think it was array or vector, probably vector. Okay, and it's for sure not empty. We can see that there are plenty of resolutions that are supported from many different displays. So we just need the dimensionalities here, and then yeah, sorting. Okay, so just sort. Each resolution is actually, I think, a tuple. What is it actually? Dimension, sorry. So it's a structure. It's comparable structure. So so there's operator that's used for sorting. Okay, and this is like the last one. It's from the list. Okay. Oh, okay. And then we erase that. Oh, and it duplicates. Okay, so we just have an iterator probably for yeah, that iterator for like unique values that gives us unique values, and then we just erase these from the original resolutions vector. Right. Okay. So it's up to 14 resolutions. Okay, from the smallest to biggest one. Okay, so now we're good. So we pick up the resolution, actually the one we just display, the one that we are looking up to. By the way, I think the resolutions which are on the list are also smaller than this one, but it doesn't matter, I think, for now. Okay, and there's what? The driver parameter boolean. So we can get the, what was that? Okay, just a string list, yeah, the name suggests. So we look up for this parameter, no mask capture. Okay, what's that actually? All right, it was empty. Yeah, it was empty. So this was the string list was empty. All right. Oh, so we're given this list. Okay, so we start but with the empty parameter list in this case. So so this will always return false. And if I were to guess, mouse auto capture is if you Yeah, okay, it's displayed. By default, SDL captures the mouse while the button is pressed. This is annoying during debugging when OpenTTD is suspended while the button was pressed. Okay, yeah, so mostly for the debugging purposes. Then, what happens? Find startup display. Obviously, we don't have any parameters here, so this will just, I will guess it will just return the default. Yeah, here. So this will be, so have no value and we'll just return default. Okay, let's see, find startup display. And we know it's -1. It's converted actually to unsigned integer. And we have the, we just query the number of displays. It's inside BS. Okay, so what it is? -1, -0 is inside. It's not. Mouse pointer decide which display to use. Okay, so we read the mouse pointer. And here it is. And then we check. That's interesting. So the SDL allows us to just check for a particular display. Just to pick up the rectangle and just, okay, so we read the rectangle for the display. And then we check if this particular mouse point is inside the display. That's how I read it. And again, yeah, okay. And if it hits, yeah, then we say, okay, so this is the display that we select, display 0. Yeah, so this is like the global position in the system, X, Y, and this is the width and height of the screen. Okay, so we know what's the display that's being picked up, and then we try to create main surface. So I would, let's see, so we pick up the available video mode. So there's no full screen, so this will return actually. Okay, so it stays as it is. Okay, and then we create a main window of the specified width and height. Okay, and this is a null pointer, so it should be fine. So there are two STL flags. The first is that we want to show the window, so make it visible and also resizable. It's not a full screen, it will be windowed, and there are some positions that are not defined actually. So, okay, so we get the bounce again, so we've seen that, right? And then we probably just want to fit into this display so the window doesn't go out of the bounds of the screen. So we pick up the X, which is actually interesting because this is actually absolute position. And okay, there's the width and here's the total width we could use. Okay, and then the X and Y. It's actually, I think it sounds like a global position. So it's somehow, I guess, in the middle of the screen. Oh no, wait, because here is like the total width, and this is like our width of the screen of the window. So this is how much we are left with. And then we divide by 2. Yeah, just to make it like centered. And here we divide by 4 because there are some taskbars. Okay, decent the scope have taskbars. All right, the bottom. Yeah, probably. But if there are not at the bottom, there may be also some decent system installed, you know. Okay, and then we get the caption. And okay, so this is our revision of the OpenTTD. And then we create a window, obviously, with this caption. And okay, we have this position, X, Y, and the flags we set up. So this is like SDL window handle that we have. It's actually the pointer. I believe we won't see much here. This SDL window. It's only a pointer here. Yeah, but it was successfully created. And then we look up for this thing. I believe this is just the icon path. Out of the interest, where is it? Okay, it's in the base set. Just the file system lookup. And then we can load BMP to get an icon actually. And it's actually presented by the surface object, which is something like this. So we have like width, height, pixels, format, everything. Oh, I have access to some SDL things. That's cool. Yeah, okay. And then there's some mapping. Get the color key, which will be magenta. Okay. All right. Oh, okay. So is it like 8-bit format probably, and bits per pixel? Yes, 8 bits per pixel. Right. So we want to that's how I read it. Like we have RGB value, and we want to just figure out where is it in the map of this 8-bit bitmap. Okay, and then we set the color key. I'm not really sure what it is. So the color key, transparent pixels in a surface. It will be treated as a transparent in a blit. Okay. And we set the window icon on the window. That's nice. That's quite a cool thing that you can do with SDL. I wasn't aware of. And then we just release the BMP. Okay, so we basically have an icon for the window, and the window is ready. So we can return from here. It was successful. I think there was no resize, so nothing to do with the window. And this is some client size changed. It's called on the driver. Allocate baking store. Okay. Okay. All right, so we get our screen depth from the blitter, which is 32 bits. And then we get the window surface. Oh, okay, something showed up. Can I actually show that? Okay, I hope it's visible, but there is like a window there which is kind of showing that something was allocated, but it was just like some random stuff was picked up from the screen, so nothing is yet there. But okay, we get a window, right? So at this point we're good. And this is SDL surface, so it's actually, while the window represents just some abstraction over the system window, this is just like a surface that we will draw on inside this window. And we check just if it was allocated, and then we just check, I think, if the size matches. And I believe it should. Yeah, it should, but it didn't pass. Okay, because the force was false. Okay, so we check. Oh, there are two surfaces. So real surface and RGB surface. So RGB surface is not set up yet. For any previously allocated, nothing yet set up. And then we just say that the real surface that we just get is actually the surface. I think it's the same set here. SDL surface, real surface, RGB. Okay. And then what do we have here? We have this our screen global variable draw pixel info. Okay, so this is like okay, some zoom level, some pitch, lofted with some destination, and the pointer. So obviously width and height from the surface. And then this surface has a pitch. Can we see what's there actually? Again. Okay, there's in the pitch. So am I able to see that actually? Oh, it's global, okay. But we can read that the pitch is here, and then we can also divide it, and the final value is, okay, this one. Okay, yeah, it's related to, it's just related to how many bits per pixel we have. So it's like, it seems like a width multiplied by the bytes per pixel. Okay, and then we have also video pointer actually, which is our surface pixels. Our surface pixels. Yep. So it's actually the pointer, but I assume it's just the void pointer, some place that we will write into. Okay, and then the last thing to do for this allocation is just the mic palette. Okay, since it's empty, we just allocate palette, which is 256. Okay, and what is this number of colors? For each color, we have like this, the structure. Okay, it's allocated, and then we copy the local palette. Oh, so the driver also has a palette, the base driver for SDL. And what do we do? Okay, so we have a log for this palette. And then we have a local palette, and it's copied from the current palette, which apparently is something. Okay, we already have some colors selected here, so I will read. Okay, and we just copy. I'm not sure what's this first dirty element. I'm not really sure what means the dirty element. We will learn later. That's my guess. And then we just update the palette, and then for this local palette for the driver. So we copied, so initialized the local palette from some global palette. And then we said, okay, all these things are dirty. So we get the first dirty element, and then we just pick the component, and we transfer it to this local array here. So this will be just a copy here. Okay, and jumping here, we just said, okay, the SDL will use this palette now. Okay, so this is a full range. Like first 30 is 0, and this also. Okay, anyway. I don't know that much about the palettes in SDL, so we'll see later what it means, probably during drawing. So anyway, while this palette is set up, the global palette is also attached to the surface. All right. So we have this assignment that the SDL surface is a real surface, so nothing happens here. Yeah, some edge case maybe. Okay, and so now we are done with allocation. It's successful. Again, we copy palette. Not sure why, but okay, to do similar thing. And then we get our blitter and we call boss resize because yeah, the client size changed. Yeah, we have a new window, so the blitter has to be notified. So pick our blitter. And what happens here? So this has some anim buffer width and height, which was not set up apparently. So we just now tell, okay, this is the buffer you're gonna use. And there's also the pitch, which is a bit bigger than what we have with the width. Okay, and then we also make the allocation, which is here, yeah, just the pointer to 2 bytes unsigned integer. And just an array here. All right, and then there's some just casting, anim allocation. Yeah, so we just cast it as a buffer. Yeah, because we just want a regular pointer here to this array. So I assume it will be pointer to yeah, we just make a smart pointer to arrays, and then yeah, and then we just need like a regular pointer, and that's why this casting here is required. So okay, if Blitter is initialized, there's still game state change to be called. And then again, we just make sure that the current resolution is set up to the screen. And then we call screen side changed. I think we did it again. Okay, subdivision, dirty block width 34. Dirty blocks per row, 21. Okay, so we it seems like we just divide. Oh, is it constant? Yeah, it's constant. We have some blocks like 64 in width and 8 in height. And that gives us how many blocks per column per row. And then we have this, which is just a vector to be resize. Actually one-dimensional, so blocks are flattened. And okay, so we check the dirtiness here, which actually does not trigger, right? That's how I read it. Okay, cursor is not visible, and oh, this is interesting. Video driver get instance. I think there was already some video driver. Oh, okay, it didn't trigger. Okay, and then we have the relocate all windows. close window bus class. So drop down menu. Okay, but again, this is about like the internal game window. So there's nothing to happen here. We don't have the windows. So this function will not do anything really. And mark whole screen dirty. Add dirty in block or the whole screen width. Yeah, so what I would guess, the dirty means that there are some parts of the window that we want to redraw when they are marked as dirty, and we don't want to redraw the whole screen every time probably because of some performance reasons maybe. All right, and then we just make sure that these attributes don't go beyond the bounds of the screen, and so on. So this is relative bottom right to the screen coordinates. And then we have this dirty block width. So we just make sure that this is right and height. It's actually in the block coordinate. Okay. And then we just go from left to right. So for each block, what happens per each block? So we calculate the offset. And then we just fill it with the transparent color, I guess. I think this was some, yeah, or maybe, yeah, just white. I don't know what would it mean here. Is this reference to palette? That's like my first guess, but maybe just fill everything with so that it represents the white. So in any case, you can see that it just gives us the nice white, the nice, like, okay, I'm not sure if it's really white. It's like we just fill it with FF hexadecimal value. And these blocks, as I remember, yeah, these were like just flat. They're just flat, and in the previous methods, previous functions, it was just initialized as that, as a flat region. Okay, so we're almost there. No full screen. We have a main surface. It's created, and then there's some driver name, which is here's X. Okay, we can just we can actually log that. Let's see, X11. Okay, yeah, it's X11 driver. That's true. And okay, this get name. What was the name here? SDL, right? Because the driver was SDL based. X11. Okay, again, mark whole screen dirty. Yeah, we've been here. Stop text input. Oh. Stop receiving any text input events. All right. All right. So whenever we try to type something, it will just. I think it's something different than just the key input, right? It's a different kind of event, I guess. Okay. Edit box is not focused. We don't have any parameters, so this will be empty and this will be empty. So game will be threaded, I believe, which is fine. And then the last thing that we started the driver actually. That is our driver. And then we say, okay, we successfully probed the driver, and then just make sure that this new driver is actually our active driver, so it's being replaced here. That's nice. Yeah, so as you see, X11, we probed the video driver SDL. We have the window actually, so we can get back from our function that initialized the driver. And then what we have next is the sprite sorter. And again, okay, so we have some sprite sorters here. Parent sprites and sprite checkers. Okay. Okay, so okay, viewport sort parent sprites SSC for one checker. Okay, so it checks the CPU flag, so it will check if my CPU has probably SSC enabled. And boom, where are we here? Okay, CPU OTD CPUD. Oh, here, look, here's some assembly. CPU ID. This assembly really. Okay. What's this info? Info 1, info 2. Oh, okay. So there were some parameters passed. So yeah. So we have this array for elements, and then we have 0. So this is this info, A, B, C, and D. And then we have this type and CPU ID. Okay, so probably this is just the this is just assembly call here. It's cool that we could just deep dive up to here. And then this will fill our array. And then max info type, what is that? 16, okay. Max info type. All right, so some magic numbers, not really explained here. Okay, so first we just get some general, so probably this code matters. So those just some general CPU info. How many types, maybe what's type here, I'm not really sure. And then we get it filled with something else. We ask for type 1 and we just check the bit of this value, and the bit is 19. Okay, so basically this is like check the bit 19 of the second property of CPU ID, and given that we requested this type. So okay, so I believe that there are various properties of the CPU that can be queried this way, and we can just also know this has bit is simply our like internal thing here, just to make sure that the bit is flagged up. And it's probably this combination is probably for, I would guess, for SSC for 1. And I think, was it true? Yeah, it was true actually. It's fine. All right. And so that was the sprite sorter. We have some zoom level, which is minimum. Yeah, I think as far as I remember, the game allows the zoom in and zoom out. And then there's update GUI zoom. Okay. Minimum is, okay, so there's some XY scale, how much it's scaled up. And so we see it's like 180% scale up. And then we have some rounding here because we adjust to scale, probably to some interface scale. What is this scale? Give it thread. Scale traditional pixel dimension to UI level. Oh, okay, yeah, because if it's zoomed in or zoomed out, it will have some different, like, oh yeah, 4x, 2x. But okay, we stay with the normal one. So the font has the normal zoom as well, and then okay, I will expect normal, no zoom really, so normal magnification here. Social integration. I have no idea what it is. So new scanner. Helper scanning for files with social integration as extension. Okay. Okay, so okay, I'm not really sure. Do you want to look into this? It just seems like a regular scanning thing. It's just that, okay, so there will be nothing more here in terms of the code. It's just that I'm just interested what it will return. But I don't think it will be interesting to just go for all the code just to look up for the file. So maybe let's skip it for now. And then we have the network startup. And then we also have some things related to music and word generation. So I believe for today, that's sufficient amount of things to crunch on. So maybe I will leave it for the next episode. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.